review for Algebra 2. I'm just going to go through in the order that it's listed on here. If you think back, quadratics, we did back, I think that was units 6 and 7, way back in January and into February. So quadratics covered 2 units, so it'll be a little bit heavier coverage than some of the other function types on the test. We did a unit where it was all about the graphs and transformation rules and key features of the graphs and things like that. And then we had a unit where it was more about solving equations, okay? So there's a mixture of quadratics practice on this review. So in this first section, it asks us to solve each of the following equations using factoring. Okay, now I am going to go through this and factor, but I want to remind you, if you are taking the semester exam, it is all multiple choice, the entire thing. So yes, you can do the algebraic work we have learned this year and you've learned in past years, but also you get Desmos the entire test. So if you are having to take this test, use Desmos, okay? Use it to check your answers. You want to solve them algebraically and then check it with Desmos, or a lot of them, since it is multiple choice, remember, if you have your answer choices, especially for solving, you can work backward from your answer choices and check, because we talked about that with Unit 12 that we just tested on with rationals. If you have the answer choices, okay, if we're talking about a solution, you can plug the numbers back into the equation and see if they make it true, okay? Or if we're talking about simply factoring, you can put the factored form of the equation, the answer choices in, and the original general or standard form of the equation in, whatever it's given to you as, and see that the graphs match. So whether it's simplifying or factoring, you can match the graphs, the original format versus the answer choices format, okay? And if it's solving, you can graph the equation and look for the x-intercepts, because remember, solutions are your x-intercepts, or you can take the answer choices and plug them in and see which ones make the equation true. So you have several options when you are working backward from answer choices on a multiple choice test. Okay, so keep that in mind. Okay, I am going to review the algebraic processes with you though. Okay, so here, because this review is not multiple choice. So this is a difference of 2 squares, or dots factoring. You have difference subtraction of 2 perfect squares, 2 values we can take the square root of. So remember, those factor into 2 binomials. You take the square root of each, and they're nearly identical. The only difference is one gets a plus, one gets a minus, and it does not matter which is written first, the plus or the minus. And that's it. Well, that's the factoring, I should say. That's it for factoring. Now it wants us to solve the equation. So the whole point of factoring is now you can split and solve. You can set this whole thing still equals 0. You set the whole thing equal to 0 if either one of the factors, or any of the factors, if you get more than 2, equals 0, the whole thing will. So you split and you set each factor individually equal to 0 and then solve. So we would move the 6 by opposite operation on both sides. And so we end up with -6 and +6. Now, if you had had answer choices, you could have checked those by plugging them into the equation. Okay, now the other option, like I just mentioned, I will show you. If this, pull up Desmos. Thank you. You can put in the equation. So it was x squared minus 36. And we can see the x-intercepts are at -6 and +6. So if you understand x-intercepts are your solutions, when you're asked to solve an equation, you are finding the x-intercepts, you can solve it graphically, okay? Now, when they're integer values like this, that's really easy to see. Sometimes maybe they'll be decimal or fractional values, but if they're x-intercepts and you click on them in Desmos, it will give you the value. It may give it to you as a decimal, okay? But you can compare that with your answer choices if your answer choices are fractions. Okay. On B, we have GCF factoring, greatest common factor. Both of these terms have a common factor of 7x that can be divided out. So when you are taking out your greatest common factor, you're dividing it from each term. So 7x squared divided by 7x would leave us with x, and negative 14x divided by 7x would leave us with negative 2. So now those are our two factors that we split and solve. Okay, so then I'm going to solve each one. Here I get positive 2. And here if I divide out the 7, it's still 0. So I get 0 and 2 as my solutions. And I can show you in Desmos, we have 7x squared minus 14x. You can see the solutions are at 0 and 2. Okay, so I'm going to do the rest of these. Okay, I've shown you a couple by actually factoring by hand. Well, I'll do one more of the trinomials by hand too. Okay, to just refresh on that. But then the rest, I'm just going to use the calculator because that's what you should be doing on the test. So this one has a GCF here. They all have an x. So we're going to factor out the x first, and then that will leave me with x squared minus 6x minus 7. Now this factor still needs to be factored further because it's still a quadratic trinomial. So I've got the x in front, but then I'm going to try and factor that quadratic trinomial into two binomials. So the factors of x squared are x and x. So now, because that was an understood 1 in front there, I'm just looking for factors of negative 7. The fact that it's negative tells me I'm going to have 1 plus and 1 minus. So the factors of negative 7 that would add to negative 6. Well, there's only one set of factors of 7. It's 7 and 1. Okay, so we would want the negative to be the 7 and the positive to be the 1 so that it adds to negative 6. So this one has 3 factors, and I'm going to split and solve each of them. Now the split and solve step, some of you don't have to write that line that I just wrote. When you see the individual factors, you'll see, okay, that's 0. And then it's the opposite signs here when there's no value coefficient in front of x. So this is going to be positive 7 and negative 1. So 0, 7, and negative 1. And I could confirm that over here. I could say x cubed minus 6x squared minus 7x. And we can see it crosses the x-axis 3 times. It's 7, 0, and negative 1. So I've been able to confirm everything by looking at the graph here. Okay, so, and I don't have to just confirm using the graph. I can just look it up. So that's what I'm going to do for these remaining 3. So for D, I've got 6x squared plus 7x minus 3. Okay, and so I can come here and I can see it's at negative 1.5 and at positive 0.33. This is what I just said a moment ago, that if it shows up as a decimal instead of a fraction. So those, I know what those are as fractions. Okay, so I'm using Desmos. And I get negative 1.5. And you can leave it as 1.5, or you can rewrite that as negative 3/2. Okay, if your answer choices are fractions, just type them out to see what they are as decimals and which one matches if you're not sure how to convert. Okay, and we get 0.33 repeating, which is 1/3. So we get positive 1/3 and negative, and I'm actually going to write that one. I don't like to have one decimal and one fraction answer. I like to be consistent. So I'm going to put that one as a fraction as well. We get negative 3/2. And I just did that using Desmos. So I'm going to do the same thing with E. I'm going to say I have 3x squared plus 3x minus 36. And I can see my x-intercepts at -4 and +3. Oops. All of a sudden, -4 and +3. Okay, let's try it with F. Yeah, 32x squared minus 2. Happening at 0.25 or 1/4. And negative 0.25 or negative 1/4. So I'm going to come over here and I can put plus or minus 1/4, or you can list them separately, whatever you prefer. Okay, I'm going to go ahead and do that with this one as well. Now this one is a cubic, okay? It's not a quadratic, okay? But you solve them the same way with factoring or by looking at the graph, okay? So it doesn't matter what level polynomial it is, squared, cubed, the 4th, 5th, 6th power, any polynomial, any type of function, you can just look at the graph and find the x-intercepts if you're asked to solve. Now, to graph it properly, it does have to be set equal to 0, which all of these are. But if you come across an equation, no matter what form of equation, like if it's absolute value or polynomial or rational or log or exponential, anything, okay, or radical, you have to get it set equal to 0 to be able to see the graph accurately, to look for the x-intercepts. Okay, we'll come across some later in the review that are set up differently, and I'll show you some options for those. Okay, but these are all set equal to 0 for you. Okay, so this one is x cubed minus 3x squared plus 6x minus 18. I'm going to have to zoom out to see this graph. And you can see this is a cubic. It does not come back up and cross again. It doesn't change direction. Okay, so that is just one solution. It's just 3. Okay, let's try it for G. For G, it's x cubed minus 2x squared minus 9x plus 18. Okay, so this one is a cubic, but it changes direction a couple times. Okay, so we end up with 3 solutions. There's 3 places where it crosses the x-axis. So at -3, +2, and +3. So positive and -3 and at 2. So those are all my solutions. Do y'all feel confident in using Desmos to find solutions? Okay, you're just looking for x-intercepts. Okay, I'm going to write that up here. When you're solving, you are finding the x-intercepts. So you can do that by looking at the graph, or you can do it algebraically. All right, we're going to continue with quadratics here. This is using quadratic formula to solve, but again, you don't have, you have a multiple choice test. You don't have to use it or solve them doing a specific method. Okay, we just went over a couple of factoring refreshers, so I will do one of these with quadratic formula, but all of these can also be solved by graphing as well. The only thing is, oftentimes, if you're having to use quadratic formula, it's because it's not factorable, which means your solutions could be irrational or values that wouldn't show up on the graph. okay? Or that might be some decimal that you can't convert. It might be a non-real number, an imaginary number, okay? So we're going to try a couple of these and see if we can find them graphically. And if we can't, then you do have to be able to just plug and chug into this formula, okay? So I'll start with A. Here, I can identify A, B, and C because it's AX squared plus BX plus C when you're in standard form. Okay, so all those ABCs need to be identified first. So A is 4, B is 6, and C is 1. So now I'm going to plug those in to the quadratic formula. So negative B is 6 plus or minus the square root of B, which is a 6, squared minus 4 times A, which is also 4, times C, which is 1, all over 2A, and A is 4. So you could do this piece by piece if you wanted, or you could do this all at once in Desmos. So let me show you how you could type this in. And when you want a fraction, I always hit the divide button first to get the fraction, and then I'll type in the numerator. So I have negative 6. Now I cannot do plus or minus. So I'm going to have to do plus and then change it to minus to get the other solution, or copy it and change it to a minus, whichever you prefer. So I'll start with plus. Okay, and then the square root is down here on the keyboard. Okay, and then it is 6 squared. I am in the habit of using parentheses around anything I'm plugging in, especially if it's being raised to a power, because if that B value was negative, you need to, if you don't use the parentheses, you will get it wrong. So I would just always use parentheses there around that B value. So minus 4 times A times C, and then that's all over 2A. Okay, so I could type it in like this, and this is what I was talking about. We get an irrational number. Okay, so this isn't one, I know what it is as a decimal, but guess what? You have answer choices. Your questions are multiple choice. So you may get this fraction for an answer in your multiple choices. You can just plug those fractions in and see what they are as decimals and match it to this. Does that make sense? So you can plug your answer choice fractions in and see which one matches this decimal. And then we need to do the same thing, but with minus here instead of plus. So we change that to a minus and we get our second solution. Okay. So in Desmos, that's what you can do. Just plug it all in and see what you get here as a decimal. Or if I were to graph this, let me change this to show you the graph. So if I graphed 4x squared plus 6x plus 1, you can come over here and you can click on these values and look, they're those decimals that we just came up with here. Okay, that's that same value, isn't it? Okay, so maybe it's easier to you to just type in the function as it's written in Desmos, go and click to look on the x-intercepts, and then match those to your answer choices. Okay, remember you may have to type your answer choice fractions in to see what they are as decimals and see which ones match. Y'all okay with that? So that's how you can check it in Desmos. Okay, now to get the actual fraction answer, I'm going to actually simplify this, not all at once in the calculator. I'll do step by step. So I'm going to do what's under, that's a 6, not a B. So negative 6 plus or minus, and then down in the denominator, that's an 8. Now I'm going to simplify what's under this square root. So 6 squared is 36. And then 4 times 4 times 1 is just 16. So we've got 36 minus 16 is 20. So we've got the square root of 20 under there. Okay, now if you can simplify, you should simplify. Okay, but again, you can just match backward from your answer choices by plugging those answer choices in and seeing what they are as decimals. Okay, but if you remember your factor tree for 20, you could do 5 and 4, and then 2 and 2, and you can see you have a pair of 2's. So the square root of 20 could be written as 2 square root, and then the 5 is stuck underneath. So I could simplify that to -6 plus or minus 2 root 5 over 8. And then remember that triangle there. If this can reduce some, you'll want to reduce it. All of those can be reduced by 2. They all have a common factor of 2. So I can simplify that a little bit by saying -3 plus or minus root 5 over 4. And then if you wanted to confirm that that's what it comes out to, I can show you real fast. -3 get it up here in the plus the square root of 5 over 4. And look at that decimal. That comes out the same as this, doesn't it? Do y'all see that? So had that been an answer choice, you could have just typed this in to see what it is as a decimal and saw that it matched your x-intercept from the graph. Okay, and then you could change that to a minus and see the other one. And it matches that other one. So that's a confirmation for me that that's correct. Okay, so that's how you do the quadratic formula by hand. But again, I just showed you all the ways you could do it in Desmos as well, since you are going to have multiple choice questions. Okay, just type your answer choices in. They're going to be in this format. Okay, you don't know what that is as a decimal off the top of your head, but Desmos will let you type that in and you can see what it is as a decimal and then match it to the graph, the x-intercepts of the graph. Okay, so for the rest of these, I'm just going to type the equation in and get them as decimals. I'm doing C right now. So -2.5 and 1. So that one actually came out as rational numbers. Okay, and then I'm going to do the same thing. I will check B and D. So this one is x squared plus 2x plus 2. Notice, does this cross the x-axis? The x-axis is down here. So this one does not cross the x-axis. So I immediately know that my solutions will be imaginary because this has no real solutions because I don't see it crossing. So imaginary ones, that is trickier. You do have to use the quadratic formula here if it doesn't actually cross the x-axis. So I'm going to identify my A, B, and C and plug into quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm going to simplify. Now under the radical, 2 squared is 4. And over here, 4 times 1 times 2, that's 8. 4 minus 8 is -4. And this is why it's imaginary, because you have a negative under a square root, which you cannot do. This is where the imaginary numbers come from. So remember, when we take the square root of a negative, that we get I. Now the square root of 4 is 2. So this whole expression right here, square root of -4, is going to be rewritten as 2i. So we have negative 2 plus or minus 2i over 2. So I replaced the square root of 4 with 2i. Now I can still reduce. Looking at that triangle of those numbers, those all reduce. They're all a 2. So they'll reduce down. This will be a negative 1 plus or minus I. I don't have to write 1i. That's understood. And then I don't have to put over 1. Okay, if you have a denominator of 1, that's understood. So that's as much as I can reduce it. So it is the imaginary numbers, negative 1 plus I and negative 1 minus I. Okay. So let's see if D has real solutions or imaginary. By looking at the graph, see if we can just get the answers from the graph or if we're going to have to do quadratic formula again. Minus 2x minus 7. So this one we can see crosses the x-axis. So this one has real solutions, okay, at irrational numbers, but that's okay. We could plug our answer choices in and see which one matches these decimals. So I'm just going to write them as those decimals for now. Okay, I used Desmos, and you should match to your answer choices. Okay, so plug your answer choices in to see what they are as decimals and find which ones match that. All right, next up is rewriting powers, roots, and radicals. So we want to rewrite the expression with positive exponents and evaluate where possible, okay? So some of them have variables we won't be able to evaluate, but some of them are just numbers and we'll be able to evaluate. Okay, so we're just remembering exponent rules here. Okay, so the fact that you have a negative exponent here in this first one, we know that a negative power means that we can move this term to the denominator, because right now it's in the numerator. So, and there's nothing multiplied out front here. It's an understood 1. So that's what's left in the numerator is an understood 1. Okay, and so this negative 3 goes to the denominator, and that power, that negative 4, can change to a positive 4 because we moved the term to the denominator. Now, you can use Desmos or you can just calculate in your head, but negative 3 to the 4th power is 81. Okay, negative 3 times negative 3 times negative 3 times negative 3. Okay, so we have 1 over 81. So we evaluated that one. Now, did you have to convert that by hand and do it by hand? No, you get Desmos. You can use Desmos. So you could just come over here when there's no variables. These are just numbers. Type in negative 3 to the negative 4. Now, it gives it to you as a decimal, but then you could type in your answer choices. And when you type in 1 over 81, you can see it matches that. Okay, so again, you can work backward from your answer choices or use the calculator to at least check your answer choice, check your work. All right, now in B, we have a variable here. We've got X, so it's not just evaluating, so we can't just type that in and get some number answer necessarily. Now, the fact, actually, I say this before I looked at it carefully, the fact that the variable is to the 0 power actually changes what I just said, because you need to remember the exponent rule that anything to the 0 power is what? Not 0. Anything to the 0 power is 1. So anything to the 0 power is 1. So that is 4/8, which is just 1/2. So we were able to evaluate that one, but only because the power was 0. Okay, if the power was something else, like here in C, we've got a cube and a square, we're not going to be able to evaluate this, but we can simplify it. Okay, so you need to remember, if you have parentheses with the power outside the parentheses, the power goes to everything inside. So the 2 is being squared and the x is being squared. So 2 squared is 4, and then that's x squared. So that's that part, and we're still multiplying this by 3x cubed. So when you are multiplying, you'll multiply your numbers, your coefficients, so 3 and 4, that's 12. And when you're multiplying like bases, like they're both x terms, you add the exponents. So that is x to the 5th. Now, you couldn't have solved that in the calculator, but you could check it. Look at how I could check to see if I simplified that correctly. Because I could type in the way that it's written. It was written as 3x to the cube, 3x cubed times 2x squared. So I could look at the graph of that, and then what I simplified it as 12x to the 5th, and notice that graph that appeared. It is the exact same graph. So I can confirm that I have simplified that correctly because they are still equivalent. They graph exactly the same. If they weren't equivalent, you would have a different graph. If I had accidentally, say, thought that I should have multiplied those powers, and I had said to the 6th power, you would see I get a different graph. Okay, that's not the exact same graph. So I did something wrong. Okay, but if you have simplified it correctly, you should have the exact same graph. So again, you can work backward from your answer choices. Type the way that it's originally written, type in your answer choices, and see which one is the exact same graph as the original expression. Does that make sense? So even with just simplifying, you can check it with the graphs. All right, let's see here. Simplifying on D here, you've got to first drop these parentheses. So that squared is going to the a to the 5th and to the b. Okay, so in my denominator, I'm going to have the 2 from the front, and then that's going to be a to the 10th, because when you raise a power to a power, that's when you multiply, and then b squared. And then my numerator hasn't changed at all. Okay, now when you're dividing, obviously, divide the coefficients. So 8 divided by 2 is 4. And you subtract the exponents of the like base terms. So 4 minus 10 is -6. But I don't want to have a negative. It said to write my answer with positive exponents. So instead of having in the top a to the -6, I'm just going to put a to the 6th in the bottom. Okay, and then b to the 6th over b squared, 6 minus 2 is 4. That's positive, so that's in the numerator, so b to the 4th. So that's how that would simplify. Now again, if it was multiple choice, you could have just typed in the original, typed in this answer choice, and you can confirm that they are the exact same graph. All right, so over here, let me get rid of these parentheses by distributing that power. Now, that is a -3. So a -3 squared is going to be a +9. X doesn't have a power, it's an understood 1, so that's just going to be x squared, and then that'll be y to the 4th. Okay, now nothing changed here, except I'm going to rewrite this with the, instead of a negative power, I'm going to move that x to the denominator as x cubed. So I got rid of the negative by putting it in the denominator, and then that 4 is still in front. So now I'm going to simplify. I've got two y terms being multiplied in the numerator, so I add the exponents. So that's y to the 8th. And then x squared over x cubed. So if I subtract that, I get -1. So that means that x has to stay in the denominator to be a positive 1 power. And I don't have to write a 1 power. It's understood. Okay, and then the numbers, I still have to multiply. So we do our 4 times 9 is 36. So that's as much as I can simplify that one. Again, I could confirm that by typing the original and typing this in Desmos, and they should be the exact same graph. And then actually, because that has two variables, it has x and y, I'm actually not positive. You can check that one in Desmos if there's multiple variables. So you do want to be able to simplify these. All right, let's get rid of these parentheses here by distributing that -2 power. So my denominator is now -2 times -2 is positive 4. And then 4 times -2 is -8. And then up here, I can drop those parentheses because there's nothing outside them, so they're not technically needed. Now, before I start adding or subtracting anything, I'm going to get rid of these negatives by moving these terms that have negative powers. I'm going to rearrange where they are. Okay, so I'm going to leave the 20 and the 8 alone. The a to the 4th, leave it alone. That a to the -4th, I'm going to move that to make it +4. So right now it's in the numerator, so I'm going to move that to the denominator. B to the -2, I'm going to move it to the denominator, so it's +2. And then b to the -8, I'm going to move that one to the numerator, so it's +8. So notice I just rearranged what was where to drop the negative powers. So you moved it, if it's a negative power in the denominator, I moved it to the numerator. If it's a negative power in the numerator, I moved it to the denominator. Now I'm going to simplify. So the 20 over 8 is going to reduce. Both of those can be divided by 4, and that would be 5 over 2. Okay, the b to the 8th over b squared. 8 minus 2 is 6, and that's positive, so it stays in the numerator. And then the a's being multiplied in the bottom, you add the power, so that's a to the 8th. And that's positive, so it stays in the denominator. So that's as much as I can simplify that one. All right, so I'm going to stop this video there. If you have additional questions on the rest of the view, you can watch the remaining videos. Again, use Desmos.